Hey 8th graders, and welcome. I'm absolutely pumped to have you here today for this explainer on classifying matter. Seriously, today we're going to embark on this crazy journey of seeing the unseen. We are going to explore the invisible architecture of the universe. You know those tiny microscopic building blocks that make up you, me, the device you're watching this on, and even the stars in the sky? It's going to be a fantastic lesson, so go ahead and get those notebooks ready.
Okay, let's dive into this by looking at a really powerful piece of ancient wisdom from 1 Corinthians chapter 13, verse 12. It says, "For now we see only a reflection as in a mirror, then we shall see face to face." You know, this scripture perfectly captures the exact challenge we face in science today. There is this deep, fundamental reality to the physical world, but right now, with just our naked human eyes, we literally can't see it face to face. We're really only looking at reflections and representations. So we have to build tools that act kind of like that mirror to help us understand the reality we just can't touch yet.
So, here's our roadmap for today's explainer. We'll start with the invisible world of matter, define what scientific models actually are, and then look at 3 specific types you'll be using. After that, we'll cover the limitations of those models, do a quick knowledge test, and finally, wrap up by seeing how education, morality, and peace all tie together. Let's get to it.
All right, Section 1, the invisible world of matter. Think about it like this. How exactly do you figure out how a house is built if you are never, ever allowed to look at the bricks? That is the exact dilemma chemists and physicists are dealing with every single day. The fundamental building blocks of our universe, atoms and molecules, are simply too small to observe directly. To put that into perspective, a single drop of water contains over 1 billion trillion atoms. Because we lack the physical superpower to just see these atoms, we are essentially blind detectives. We're trying to solve the ultimate mystery of matter, but we're working in the dark. We need special tools to help us visualize and communicate our ideas about what on earth is happening down at that microscopic level.
Moving right along to Section 2. What are scientific models?
This brings us to the ultimate tool that scientists use to solve that invisibility problem. A scientific model is basically a tool scientists use to explain, visualize, and predict structures and behaviors of matter we can't see directly. Think of a model as a pair of scientific glasses that suddenly snaps a really blurry world right into sharp focus. And they don't just help us draw pretty pictures, actually, it's way more practical than that. By using a model, we can genuinely predict how substances will behave before we ever even mix them in a lab. This is absolutely essential for things like medical research and manufacturing. I mean, if you're creating a life-saving medicine, you absolutely need a model to predict how those invisible molecules are going to interact inside the human body.
Okay, Section 3. 3 types of models.
Now that we know why we need them, let's break down the different categories of these tools you'll be using in class. There are 3 main types. First up, physical models. These are the tangible objects you can actually hold in your hands. Next, we have computer models, which are digital simulations. They need some serious processing power. And finally, drawings and diagrams, where we use specific symbols to represent atoms and their arrangements right on a flat piece of paper.
And this brilliantly illustrates the difference between them. On the one hand, imagine a physical ball and stick model of water, H2O. It takes 2 hydrogen atoms bonded to 1 oxygen atom and enlarges them to a visible size, right? It shows you the exact static bond angles perfectly. You can literally hold it, spin it around, whatever. But on the other hand, consider a computer simulation of a gas. You obviously can't hold it, but it displays the random, rapid, chaotic movement of gas molecules just zooming around a container. The physical model helps us see static structure, while the computer simulation helps us visualize dynamic, rapid behavior that explains exactly why gases expand to fill up a whole room. 2 different models, but equally vital purposes.
Now here's something pretty wild. A model you already know really well? The periodic table. It is actually a model itself. It's a diagram that organizes the elements by their properties and atomic numbers. Just by looking at where an element sits on this table, a scientist can actually predict how it's going to react and combine with other elements. It's honestly one of the most powerful predictive models in all of human history.
That brings us to Section 4. Limitations of scientific models.
So, we've talked about how amazing these tools are, but now we kind of need to shift gears and discuss the catch. I really want you to think about this for a second. Are scientific models perfect replicas of reality? Like if I hold a plastic ball and stick model of water, is that exactly what water truly is?
The short answer, no way. So the crucial point is that every single model has limitations. They're kind of like funhouse mirrors or even video games. They literally cannot show every single detail. In fact, they intentionally exaggerate certain features and totally ignore others just to make specific concepts clearer. A plastic ball and stick model totally ignores the fact that atoms aren't actually hard plastic spheres, and it exaggerates the chemical bonds by making them look like literal wooden sticks. But it does all of this so you can focus on the core lesson, the structure and the angles. You just always have to remember that a model is a helpful representation, not the whole complete reality.
All right, Section 5, Testing Your Knowledge.
Okay, 8th graders, it's time for a quick homework check to see how well you've grasped all these concepts. I challenge you to pause this explainer right here, grab your notebook, and answer these 5 questions. 1. Name one benefit of using models in science. 2. Give one limitation of a model. 3. Describe a model you've used in your class before. 4. Explain why scientists use different types of models rather than just relying on one. And 5. Create a simple drawn diagram of a molecule you know, like maybe water or carbon dioxide. Take your time, work through these, and really lock in what we've learned today.
And finally, Section 6, Education, Morality, and Peace.
As we wrap up today's lesson, I want us to kind of zoom out from the microscopic world of atoms and look at the big picture of your life. And we're going to pull from the philosophy of the Heroes Smart Academy Godly Learners series for this. We just learned that scientists absolutely need frameworks and models to prevent themselves from just blindly guessing in the lab, right? Well, the Heroes Smart Academy philosophy teaches us that humans need a moral framework just as desperately. Their philosophy states that education without morality will ultimately hurt. Think about it for a second. What is the point of being incredibly smart, knowing everything there is to know about chemistry and physics, if you continue to make blind, bad choices that hurt yourself and the people around you? Intelligence without a moral compass is basically like having a super powerful rocket, but absolutely no steering wheel.
This is exactly why true education intertwines with biblical morality. Romans 8:6-7 promises peace of mind to everyone who keeps their mind spiritual. It's an incredible promise, and it's a reality that people experience every single day. Genuine peace and truly successful learning really come from keeping this spiritual focus completely intertwined with our educational pursuits.
So I want to leave you with this final provocative thought. Through science, you now have the models to understand the invisible architecture of matter. You have the tools to build, invent, and discover some amazing things. But do you have the moral compass to ensure you use that knowledge to make the right choices? Keep learning, keep questioning, and keep building that compass. Thank you so much for joining me for this Explainer 8th graders. I will see you next time.